Kubernetes, also known as K8s, is an open source platform that automates deploying, scaling, and operating containerized applications. It helps manage clusters of computers to run applications efficiently without worrying about the underlying infrastructure. Here's a simple guide to understanding Kubernetes and how to put it into practice. So what is Kubernetes? Kubernetes is a system that manages containers, which are lightweight, standalone packages that include everything needed to run a piece of software, code, runtime, system libraries, etc. Think of it as a container orchestrator that ensures your applications run smoothly by automating tasks like deployment, scaling, and load balancing. Kubernetes Concepts. To use Kubernetes, you need to understand some core components. 1. Cluster. A Kubernetes cluster is a set of machines that run your containerized applications. It has two main parts: master node. This manages the entire cluster and makes decisions on scheduling and scaling. Worker nodes. These run the applications inside containers. 2. Nodes. Nodes are the individual machines, physical or virtual, in your cluster. Each node has a kubelet, a small program that communicates with the master and ensures containers are running as expected. 3. Pods. A pod is the smallest deployable unit in Kubernetes. It can hold one or more containers that are closely related and share resources like networking. If your application is split into several microservices, each might run in its own pod. 4. Services. A service defines how to access your application, for example, via an IP address or DNS, and balances traffic between pods. 5. Deployments. A deployment ensures a specific number of pods are always running. If a pod crashes, the deployment controller replaces it. 6. Config maps and secrets. These store configuration data, for example, environment variables, and sensitive information, for example, passwords, separately from the application code. So how Kubernetes works? Here's a step-by-step overview of how Kubernetes works. 1. Create a cluster. First, you create a cluster that includes a master node and one or more worker nodes. Each worker node can host multiple pods. Kubernetes automatically distributes the pods across nodes based on available resources. 2. Deploy an application. You deploy your containerized application to the cluster. Kubernetes makes sure the specified number of pods are running and healthy. You write instructions in a YAML file, which describes your application's configuration, including the number of pods and the type of resources each pod needs. 3. Scaling. Kubernetes can automatically scale your application by increasing or decreasing the number of pods in response to the load on your app. This ensures your application can handle spikes in traffic. 4. Rolling updates. When you update your application, Kubernetes can perform a rolling update, where it gradually replaces old pods with new ones without downtime. If something goes wrong, it can automatically roll back to the previous version. 5. Self-healing. If a pod fails, Kubernetes detects the problem and either restarts the pod or replaces it with a new one. Let's put Kubernetes into practice. Now that you know how Kubernetes works, let's see how you can deploy an application using Kubernetes. Step 1. Install Kubernetes. To use Kubernetes locally, you can use a tool called Minikube, which creates a Kubernetes cluster on your computer. Follow these steps. Install Minikube by downloading it from the official website. Install Kubectl, the command line tool for interacting with Kubernetes, from the official Kubernetes site. Once installed, start Minikube by running Minikube start. Step 2. Create a Kubernetes deployment. Create a YAML file named deployment.yaml. This file tells Kubernetes how to deploy your app. In this file, we're creating a deployment named MyAppDeployment that manages 3 replicas of an Nginx container, which is a lightweight web server. Each pod runs the Nginx container on port 80. Apply this configuration by running kubectl apply fdeployment.yaml. Kubernetes will create 3 pods, each running an Nginx container. Step 3. Expose the application. To access your application from outside the cluster, you need to create a service. You can do this by running kubectl expose deployment. MyAppDeployment type equals node port equals 80. This creates a service that exposes the deployment on port 80. Step 4. Access the application. Use Minikube to get the URL of your service and access it in your browser. Minikube service MyAppDeployment, URL. Step 5. Scale the application. If you need more pods to handle more traffic, you can scale your deployment with a single command. Kubectl scale deployment. MyAppDeployment replicas equals 5. This will increase the number of pods from 3 to 5. Step 6. Monitor and manage. Kubernetes provides commands to monitor your cluster's status. For example, check the status of your pods. Kubectl get pods. View detailed pod information. Kubectl describe pod. Congratulations. See, that wasn't so hard. You've successfully set up a Kubernetes cluster, deployed an application with 3 running pods, and exposed it to the outside world using a service. Not only that, but you also learned how to scale your application with a single command, ensuring it can handle more traffic. By following these steps, you've taken your first significant step toward mastering Kubernetes. With this foundation, you can now explore more advanced features like scaling automatically, setting up monitoring, and handling real-world applications. Keep experimenting, and soon you'll be managing complex, production-ready clusters. Common Kubernetes use cases. Microservices. Kubernetes is great for deploying and managing microservices, where each service runs in its own container. C/CD pipelines. Kubernetes helps automate testing and deployment as part of a continuous integration/continuous delivery C/CD pipeline. Scaling applications. Automatically scale applications based on traffic. Best practices. Use namespaces. Organize your resources by creating namespaces for different environments, for example, development, production. Monitor resources. Use monitoring tools like Prometheus or Grafana to track the health of your Kubernetes cluster. Automate backups. Regularly backup important data such as persistent volumes. Conclusion. Kubernetes is a powerful tool for managing containerized applications at scale. As a beginner, start by familiarizing yourself with basic concepts like pods, deployments, and services. Then, try deploying simple applications using Minikube. Over time, as you explore more features like scaling, monitoring, and automation, you'll become proficient in managing complex systems with Kubernetes.